Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 2.8 absolute value functions. Alright, so today we are looking at graphing absolute value. So, first of all, essential question, how do I graph absolute value equations and functions? All right, we're looking at graphing these guys today. We looked at it a little bit earlier in the year, how to solve absolute value equations. Now we're looking at graphing them. Absolute value functions are always V-shaped graphs. They're symmetrical about the vertex. All right, the vertex is the corner point of the graph. So like this guy right here is the vertex of that V. All right, so y equals the absolute value of x right here. This is the graph with a vertex of 0, 0. Okay, so notice it's just y equals the absolute value of x. We call this the mother function. All right, so if we have a graph centered upon 0, 0, the left side of the graph is by this negative x, so it comes into there. And the right side is by positive x. So y equals negative x and y equals positive x. So we're looking at a V-shaped graph. And notice that the slope of this side over here, slope is 1. Okay, and this side over here has a slope of negative 1 because it's going down 1 and over 1, down 1 and over 1. So both sides of that graph. All right, this guy right here, we are looking at y equals a absolute value of x minus h plus k. All right, I kind of like to put this h in parentheses because we always have to look at that guy as whether it's going to be positive or negative, and we're going to look at that a little bit here. So this a, h, and k always make translations to this mother function. All right, so my vertex of this graph here is going to be hk. Vertex is hk. The graph opens up and looks like this if a is positive, and if a is negative, then it opens down and looks like an upside down V. Okay, so all these guys are making transformations to this graph. All right, and if I look here going on, I have to first, from the vertex, walk the slope A to the right. So walk the positive slope to the left, the opposite slope to the left, excuse me. So if A equals 2, then walk a slope of negative 2 to the left. So if K is positive, the graph shifts up. And if K is negative, the graph is shifted down. If H is positive, the graph is shifted right, and if H is negative, you shift that graph left. So to plot these guys and to actually graph these guys, you have to first plot the vertex. All right, then walk the slope in both the left and the right, and then connect into a V shape with the arrows on both ends. So that's our last part. So let's look at this first guy. We have to graph y equals negative 2 x plus 1 minus 4. Okay, and what I normally do here is I rewrite this so that that x plus 1 is really the same as minus a negative. So I rewrite this guy as y equals negative 2 absolute value of x minus, because if you notice up here it's always a minus, and then in the parentheses I'm going to have negative 1 minus 4. So now this helps me find all these guys. So I look at this guy, I know the negative 2 is my A, my H is negative 1, and my K is negative 4, so plus the negative 4. Excuse me. So now I have to plot my vertex, and it tells me that my vertex is HK, always. Always, always, always. So now I know that my H is negative 1, and my K is negative 4, so that is going to be my vertex. So if I walk that guy, I go over for -1, 1, 2, 3, 4, and there, right there is my vertex. So now you have to ask yourself, is this graph going to open up or down? Is it going to look like a V that opens up like this, or a V that opens down like that? So since this A right here is a negative, that means it's going to open down. So this guy is going to open down. And I always walk this slope here to the right. So I always start with that -2. So I go down 2 to the right 1. Down 2 to the right 1. There is the right side of my graph. Okay? And my other side is always symmetric around that x value. So I'm going to walk down 2 into the right 1. To the left 1, excuse me. Down 2 into the left 1 again. So now I connect that guy, and there is my V. So that is my graph right there. I found that vertex. Once I found the vertex, then I walked that slope of my A to the right. All right, and it always looks like a V. Always looks like a V. So now the next one asks me here to write the equation of the graph. So if it says, if you're given a graph of an absolute function, how do I write an equation for that graph? First, you have to identify the coordinate point of that vertex, okay? And you're going to plug that into the equation, y equals a, absolute value of x minus h plus k. Then you're going to walk the slope of that line to find your a, okay? Then you're going to finally write that equation using that h, k, and a. All right, so if I look at this guy here, I have a vertex right here, okay? And I can see that that vertex is over 1, 2, and up 1, 2, 3. All right, so now my vertex is at -2, 3. And I know that my -2 goes in for my h, and my 3 goes in for my k. Also, I can find here that my guy to the right, I'm going to go down 1 over 2. Down 1 over 2. So my a here is equal to -1 over 2. Now I just have to look to plug these guys in. So if I have my h and my k, I go y equals a x minus h plus k. I can plug in what I know. I know that y equals, I know that my a is -1/2, so I'm going to plug that guy in. Absolute value of x minus, my h is -2, and then I have plus my k value, and my k value is 3. So if you wanted to here, you could put these in parentheses, or you could say plus. So my final answer is going to be y equals -1/2 x plus 2 plus 3. Okay? So the only unique thing here is that your h value is kind of always the opposite of what it looks like. Okay? So here it looks like a +2, but when you pull it out, it comes out to be a -2. So it's always the opposite of what it looks like. So if you want to write yourself a little note here, h is always opposite of what it looks. All right, so this lesson and this graphing absolute value shouldn't be too bad here, is that you're finding, to graph them, you find that vertex with the h and the k, you find your slope that you're walking, and you actually make that v. Okay, so if you're given that actual graph, you have to find those things. You have to find the a, the h, and the k, and just plug them in to your final answer here. All right, so see what you can do here on this page 51 for these 2.8 worksheets. I will obviously back to help you with any questions that you have, but please do what you can, work with others, and we will see you later.